This is the first tutorial, exponential equations with related bases. We're going to look at unrelated bases. So what that means again is that, right, where those two numbers are not related to each other, 2 and 43, they're not whole number powers of the same thing. I want you first, which would be a good skill or a good thing to be able to do, is just take a guess at what you think that number would be. 2 to the power of, like, don't forget what you're doing here. If you're trying to solve this, take a guess. Any guesses? Let's get the calculator out and see how close we can guess. You play around with what you're looking for here. Take a guess. Somebody want to be brave and give me a guess here? You know it's got to be at least how much? It's got to be at least 5, right? Because if I made it 6, that's going to be 64. So it's somewhere between 5 and 6. We know just from the thing we just did that it's not 2.5. Or no, it's not. Sorry, I'm thinking of something else. What's a good try here? Between 5 and 6? You could try 5.5. You're not going to solve these by trial and error, but at the start I would like you to see all you're looking for is a number that, you know, what power works there. You could try, you could sit here and try things. 5.4 is probably too low. 2 to the 5.45. I'm sure you could zero in on it pretty quickly, right? 5.42, I don't know, something like that. There's a way you can solve it using logarithms now that you know base 10 logarithms. So you know it's going to be about 5.4 something. I'm going to say roughly 5.4. But we're going to find it pretty quickly, pretty accurately using logarithms. If you have an exponential equation and the bases are not related, this is the key for what you do. Even though that the base of this thing is base 2, you could take the base 2 logarithm of both sides, and that might be what a lot of you try and resort to. Log base 2 of both sides. Why would that help over here? What can I do with this side if I take the base 2 logarithm? What do you think? Yeah, this log base 2 of 2 to the power of, again, that's like this button. Log base 2, if you had that button, and this button, 2 to the power of anti-log base 2. Log base 2 button, anti-log base 2 button. You don't have either of those buttons, but they are inverses, those two functions. All you would have here is x equals log base 2 of 43. What's the problem now, though? We don't have this button, right? This is why it says over here, take the base 10 logarithm of both sides. If you take the base 10 logarithm, you're going to be able to solve this. So I'm going to put down here, no base 2 button. No base 2 log button. If you need to change it into that expression, you can. And eventually you're going to know how to change this into a different base. You're going to learn a change of base rule. But the simplest way, if you're going to use your calculator, is this. I'm going to put it up here. If you start with 2 to the x equals 43, I can take the base 10 logarithm of both sides. Okay, we'll move this over, and maybe we'll even do this in a different color so we can see what we're doing here. If I take the base 10 logarithm of both sides, and then I need one of my logarithm laws that we learned. How could I change this side around now? What could I do? It has to do with this. What could I do with that power? Put it in front, right? You can write that in front. You can, log of 2 to the x is the same as moving this in front, right? Putting that thing, the whole thing, in front, right? Like that. That can go in front, so it can be x times log of 2 is log of 43. Now don't forget what it is you're doing here. This is a number. This is a different number. You've solved lots of equations like that before where it says number times x equals some other number. Except that when you did it, it was probably grade 8 and it said x times 3 equals 11. How did you solve that kind of an equation? It is, yeah, you divided both sides by 3 and you got 11 divided by 3. It's no different here. If you have x times log 2. Log 2 is just a number that your calculator knows. We could actually write it out, but it's easier if you just leave it as log 2. Like we could write this out and say it's 0. Whatever equals whatever here. It's simpler if you just say x times log 2 is log 43. So x has to be log 43 divided by log 2, right? It's exactly equal to whatever that is, but you can write an approximate expression here if you go to your calculator. Depending on your calculator, you might have to watch carefully how you push the buttons. We'll get there. Remember that the number was something close to 5.4. If you put in log of 43, on this kind of calculator you have to close the bracket or else you're going to get the wrong answer because you want it to work out the logarithms and then divide. So make sure you're looking at it properly. You might have a calculator that shows it as a fraction. So it's 5.4. I said it was roughly 5.4, but that's it to quite a few decimal places. It's still approximate, even if you wrote down all those decimals, because this goes on forever. 5.4263 to 4 decimal places. You can check your answer, right? Confirm your answer by substitution. Put the number in and see. 2 to the power of, just put this number in here, 5.4263 it should be roughly equal to what it said, right? 43. So try that on your calculator. You can always check your answers to these. Anytime you're solving an equation, 2 to the power of, I'm going to punch it in again, but you could just do 2 to the power of answer, right? If I only put that in, it's going to give me pretty close to 43, but it's not exact because I rounded it off, right? You can always check when you're solving an exponential equation by subbing in the number. Are we okay with that? I think. This is going to be something you do over and over again in a lot of different problems we work with and stuff, so you're probably going to get pretty good at it. If you wanted to check your answer by graphing, we haven't looked at what these functions look like graphically yet, but we're gonna come back and talk about that at some point as we work through this. How could you check your answer graphically? You could draw a graph of the thing and see where it's equal. We're going to put later here, but we're going to make sure we fill in that concept when we get to doing some of the graphs. In general, whatever you have here, if you have a to the x equals b, solve using or solve by taking, I'm going to put base 10 log of both sides. Isolate x, or isolate x. I'm going to put using power rule. All right, but you can write it out for yourself, right? Log of a to the x equals log of b. X times log a equals log of b. X equals log b over log a. A lot of you are probably going to get pretty good at just seeing, I know the answer to this is going to be this. And that's fine. If you know that, that's actually going to be a rule that we learn here, power rule. We're gonna work on a change of base rule at some point that's going to depend on that. If you have something else involved here, the concept's not different. It's just you have to think about it the same way. The startup, everything's going to be the same, other than eventually the exponent isn't just x, it's 5x for that one. All right? Or if you have something else where you have this might be something that's probably where we're going to have to bring it back to next time. And we're going to start thinking about it. Try solving this one, problem 2, right now. Get an answer, check that you make sure it's right. Have a look at your steps compared to somebody else. Check the answer when you get it. And then we'll start thinking about this one.